Hello, everyone. Thanks for joining us for our next live session. I'll be your producer for our session, but before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer. Our session is being recorded. It will be available to view on demand right here on the Microsoft Reactor channel. With that, I'll turn it over to our speaker for today. Thanks for joining us.
Hello, everyone. Good morning, good evening, and good night. I'm Constantinos, and I'm your presenter today. I'm calling from Athens, Greece. Thank you, everyone, for joining in Microsoft Reactor. This is our second appointment on a four um, event series around MCP. So we met yesterday, and we saw a very lightweight, let's say, but quite interesting implementation of MCP. In reality, we saw how a client can connect to the Microsoft Docs MCP server, get content, right, and present it into a web application. Today, we are scaling up the complexity of what we're going to build. Before I start, I want to say a big thank you to Microsoft Reactor for making this for event series a reality. And many thanks to you guys for connecting, whether you are seeing it, watching this live or on demand. The specific implementation solution, um, while it's quite complex, it's very interesting. It has many aspects around my expectations and my, uh, uh, you know, goals, starting as more and more engaging in Azure Cloud. So what I wanted to achieve was can we have an AI engine that will be able to utilize whatever libraries, frameworks, or languages are out there to help an architect design a diagram on one hand, and on the other hand, create the first draft of an architecture. So the architect will just say the phrases, let's say a very small prompt, what is the need? Okay, we need, for example, an e-commerce platform with high availability and PostgreSQL in a high available setup with this and that, natural language, but not more than one or two paragraphs to um, describe the requirements, right? And then the engine should be able to create the diagram, at least the preliminary diagram, and the architectural document. Again, the preliminary architectural document. But imagine how much time and effort this engine would save from the architect. And I want to highlight here that this engine, it won't take the job out of the architect, right? It is a helpful assistant, okay? And I know this is maybe a cliche phrase, but it is. It is uh, a helpful assistant for the architect. It will never replace the architect's job, okay? But it will empower the architect. It will open up um, possibilities because she won't be locked into the repetitive tasks, bringing icons here and there, and they will get the first diagram and the first document. So, to tell you the truth, this was a very adventurous journey, but in the last year, I realized that this could be a reality and this could happen. And it didn't happen. And this is what we're going to explore today. So, without further ado, let's move on to our slides here. And in the meantime, I will also add some context around this project because it's really interesting. First of all, this is called AI Architect Web App. It is hosted in Awesome Azure Developer as a solution. At the end of the presentation, we will share the links. And it was also um, meant to participate in the recent Microsoft Hackathon. I was lucky enough to collaborate with a person from Microsoft that he really encouraged me about this project, and uh, he managed to make it a little bit better. We are not going to see the better version, so this is the first version, the alpha, but there is also another one that is going to be soon replacing what is currently in the awesome HD blades. So it's very interesting, um, quite glamorous, let me say. Golden was the word that the Microsoft architect used, and yeah, it was quite an experience to build this. It didn't participate in the hackathon because I had some personal um, engagements that didn't allow me to be on time, delivering some videos and some details that were needed there. But it's okay. The experience is what it matters and the learning part. So, what this thing does, it is AI powered. Okay, everything is built on Azure. It can validate and it can autocorrect while you are typing. You're going to see that in our web app. It will render the diagram, as we said earlier. It will offer us the ability to store the solution as a diagram and a document, and also export the document in the diagram. So it is producing two artifacts, this web app. Now, because I started this idea from a very minimal place, and I tend to do this. I wanted to this small thing to make it something really big. I decided to try to make it work for the awesome AZDWs and uh, the people, the community that are leading this initiative of awesome AZDWs really helped me, and they make it a reality. It was my first template that I ever published there, so it was an achievement, a big achievement for me, and I was very happy to see this template featuring in the Awesome Data Blades. Now, the construct, how this thing works. Of course, we have our beautiful frontend. We're going to see that later. That it is using React and TypeScript. It has a responsive user interface. It has a professional look, and the experience is um, quite upscale. Let's say you're looking into a professional web application. The backend is using Python Fast API that is able to orchestrate our agents. We have agents, and we are using agents from the previous version of Azure AI Foundry, now Microsoft Foundry, but it uses the previous version of AI Foundry. It it creates the agents on the fly, and then it utilizes these agents to work together. On one hand, to build the documentation, and on the other hand, to create the diagram. There is also another service. There is the MCP service, our custom MCP server that helps the agent validate the diagram and correct the agent, drive the agent to the correct direction for the selection of services, for the selection of icons, and It's using, of course, GraphViz and the diagrams library from Python in order to create this diagram with code on the background. Since we're using Awesome Azure, we have two options. Either we're going to use Terraform or Bicep. My preference is Terraform, and I'm a little bit more experienced in Terraform, so that was the infrastructure as code of choice for our Azure services. I'm sorry. So a lot of things I'm saying here and there. Agents, backend, frontend, but everything is going to be quite clear as we proceed. How it works? It's very simple. The user is able to open the web application, and asterisk here, we can also implement authentication. So in very few lines of code and couple of minutes, we are able to integrate it with Entra ID or even Entra external SIAM and make it work with authentication. The user is going to a secondary page. From the welcome page, they press a button get started, so they are able to work on a text box and write the solution that they would like to see. The agents are using the user's input as their feed. Okay, it's their feed, their data. While the first agent is able to create the design document, the second agent, we notice there, that has some limitations. So let's say here, the first thing we try to do was utilize the second agent with the um, the code tool, okay, to install the libraries of graphics and diagrams and just create the diagrams. But it's not the case here. These sandboxes that are available for our agents to execute code are quite limited. And they have the basic services, but when you try to go one step further, things are getting a little bit complex there. What we noticed was that we had serious syntax errors, bad decisions regarding what icon should the agent select and which icon is which. So, for example, if the diagram and the design agent mentioned Azure SQL, the diagram agent wouldn't recognize that Azure SQL belongs to the database family, and it could try to find this artifact, this icon from the graphics and the diagrams library in the storage, let's say. So we had many errors and the diagrams were failing. That's why we implemented this custom MCP validation engine. This engine holds all the data from the diagrams library. So it has the exact structure as you can find it in the website embedded in a JSON, if I remember correctly, yes, in a JSON file. And when the diagrams agent wants to uh, look into how can I connect an Azure SQL with the backend, which is a storage account, it will be able to find the correct icons. And by finding, I mean the correct name, right? The correct context and make the diagram appear as a correct diagram. What is needed for this setup to work is, of course, we need Azure subscription. You need AZD and Azure CLI, and you need Docker. These are the tools that are required, and without these tools, you cannot, I'm sorry, break it to your uh, workstation. You can use code spaces because the solution also works in GitHub code spaces. The solution itself is designed in a way that it is installing the required packages and it makes the developer life easier. But these prerequisites are the responsibility of the developer to be there for the service, to utilize them and using them, build the services using them. Now, there are a number of use cases for this AI architect, and I'm sure at some point in time, we as engineers and as architects and whatever is our role, have thought about this, about how we can create an AI agent that will be able to create these diagrams for us. Now, the cases are quite quite few, from simple web apps to data analytics pipelines to microservices architectures and event-driven systems to retail e-commerce websites and um, high available databases, whatever your mind can think of. Now, of course, we are based, our solution is utilizing the diagrams library from with Python that provides us everything there. So we are locked into this framework, let's say, or into this library, into these packages. But this is not an issue. Okay, this is open for everyone to use, and we're using it. What the errors that we faced allowed us to learn is that we can use AI and this MCP server to validate the architectures, as I said earlier, and correct the diagrams agent. So at every retry and every try, we won't fail. We will have a diagram generated. The diagrams are exportable, of course. We're using Cosmos DB to save them, and everything is open source. No licensing, but you need Azure subscription, and of course, you need the correct method to create the Foundry resources in a supported region. Remember that. Yes, as you see here, our frontend lives in Azure Container Apps, the same our backend, and the same for our MCP validation service. So you're going to see everything, how it works. How you can get involved, we can discuss this at the end, but since we are looking into this slide, allow me to express here that I'm quite active in the communities. So please ping me, uh, contact me. If you want to make this even better, I'm quite open. So don't hesitate to come to me and discuss how we can make this thing better. Now, since the complexity is quite high, there are a lot of steps involved. Let's take it from the number one step. So what is our application? This is what the user is getting, okay? It is a web application. You can see here, let me make it a little bit bigger here. So the usual URL, you understand here that we are having Azure Container Apps. Of course, we can use our custom domains, even certificates, and so on. But we're using Azure Container Apps because it allows us to create microservices and containerized applications in a managed um, service offering by Azure. That's very, very easy to start with containers and so on. You don't need to go deep to the Kubernetes world, but you are still into the microservices world using Azure Container Apps. One of my favorite services in Azure, 100%. This is the front end, okay? A nice web page, as we said earlier. Of course, React and TypeScript here are making their miracles. There's more miracles. Authentication can be implemented with just a few lines, and start designing is what the user needs to do. The user will write here what they want to do. While they are writing, they are getting some validation on the background. Nothing happens, nothing interferes with the user while they write their text box and their example. You can see here that we have an example just for us to recreate if we want to. We have the capability to save architectures, and here is one architecture that I have already created just before this meeting. And let's have a quick look at what we are seeing. Now, the more context you provide to your model, the better the architecture will be. So this is about an e-commerce website that I created with a small prompt, and it's quite interesting that it actually understood the scalable infrastructure that we need, implemented Key Vault without I even mentioned Key Vault. I didn't even mention Key Vault, Service Bus, and Azure SQL and application research. The very basic services that are definitely needed in this type of deployment. The actual design document is this one, where you can also copy and export, and it creates a markdown document of your design. You can see here that the design agent is quite chatty, and it has a lot of potential to provide good information about the services, how they should be, and what we should utilize. Very interesting information. Now, as I said earlier, if you remember, we spoke about version B that is about to be deployed. Now, imagine having the design agent validating using the Microsoft Docs MCP server for up-to-date information and up-to-date services, and the latest, the cutting-edge technology by Microsoft. This would be the perfect design agent, and of course, the diagram agent will follow as well. So this is very simple, okay, as it looks, but it's not. How this thing works. So allow me to take you to the Awesome Azure Developer CLI. This is a library maintained people of the community, Microsoft, and people that do have the passion to serve as community members with templates, ideas, end-to-end solutions that can be deployed with 2 lines of code. In reality, every template that lives here is able to be deployed by using this terminal command, azd init -t, the name of the repository, and then all you need to do is write azd up. You have to wait a couple of minutes, and then everything is done automatically. And this is something really, really amazing. What happens in the background is that we're getting some questions asked. We are asked how would be the default environment name. We need to be very careful here to select something that is non-common, because there could be someone that is using a very common name, and some services may fall under the non-uniqueness. So be careful when you are asked about the default environment. As I said, you need to have logged in with AZ login into your subscription and AZD auth login. Every detail is presented in the repo, and the instructions are there. The repo is it has the hyperlink here from the AZD templates library, and the instructions are all here. We can see here also a little bit of the architecture. The good thing with uh, container apps is that you can utilize Dapper out of the box. So when you are building your microservices and you want to have front-end communication and backend communication, you can utilize this sidecar that can easily transfer calls from your front-end to the backend and from the backend to the MCP service. So you don't have to work with a little bit more complex HTTP calls and API endpoints and all that stuff. Dapper takes over and is your messenger, your taxi that uh, passes on the messaging. And this is done out of the box. The only thing you need to do into your code is to work with relative URLs. Okay, and of course this works better if you're into the same Azure Container Apps environment, of course. Everything works with identity and managed identities, except from Cosmos DB, if I remember correctly. And here is the AI agent service, as I am naming it. Why? If you remember, somewhere midsummer, we saw Microsoft presenting us the AI agent service. And it presented us with this specific service that was able to create agents into the Foundry portal. So let's see what we have in our Foundry portal. Let's do it from the actual resource groups. So you will see here that we will have a resource group named with the prefix that you saw. I think it's here or in the other subscription. Let me see. Yes, this one. You can see here that the name is based on the environment name that we selected when we run AZD app. So here is exactly all the resources that are built by the Terraform configuration files, and that these two commands, azd init and azd app, and everything is built for you. It is amazing for people that are coming from another service provider, people that are starting now to get deeper into the infrastructure world, and developers that want to have more control over their deployments. Let's have a look in our services. So on one hand, we have the Foundry and the Foundry project. I'm going to return to this in a bit. Let's have them like this. We have Cosmos DB. Cosmos DB is used just for storing the diagrams and the design documents. The backend service, the frontend service, and the MCP service. We're going to have a deeper look, and we're going to also see them in action. The container apps environment, container registry, because we want to store the images, the container images from our local development workstation, and then have the container apps environment pull them and build them. We need Key Vault to store any type of sensitive information like API keys or even the managed identity credentials. By credentials, I mean the ID, right? The object ID. So it is very good practice, recommended, and you will find out if you start getting deeper into this type of deployments. Key Vault is out of the question. You need to deploy Key Vault at all costs. Log Analytics Workspace, it comes by default, even if you don't, uh, let's say, declare it while you build your services. Each time we create a container apps environment, we will also get log analytics. The managed identity used to authenticate services with each other. And you can see here what are the roles that this identity has. Very important. Azure AI user, it is a very important role. This role is for the Container Apps environment to be able to pull the images from Azure Container Registry, the Cognitive Services OpenAI user and the Azure AI Developer, Storage Blob data contributor, and Key Vault Secrets user. A lot of stuff for this managed identity, and also saves us a lot of time and effort as it is used globally and between multiple services to authenticate to each other. Now, let's see here this Foundry service. What is this and why it matters? So as we discussed a few moments ago, we saw around somewhere, maybe even earlier, Microsoft presenting us this Azure AI Agent Service. So what is this? Allow me to show you. The Microsoft Azure AI Agent Service, it is a managed platform for securely designing, deploying, and scaling AI agents. It was, let's say, the first version of agentic capabilities in Azure AI Foundry. It came quite easy to use it, and if you go to the relevant URLs, the documentation provided by Microsoft, you will see that you have let me find the correct link. You have the capability to build this in different ways. So let me find the correct link. Give me a moment for this. I think it's here. Yes, and also here where you're getting this AI agent service ready to be deployed. So it, the documentation provides us a link to deploy to Azure directly. And what it deploys, Microsoft Managed Key Vault, all necessary RBAC permissions, AI project with GPT-4o model deployment. It is required, and I don't know if this has changed, but until that moment, GPT-4o was a model of preference for our AI agents. And these are the regions. Here you will find the regions that are supported for our agent service. And here are the models. Yes, since we are looking into it, here are the models. You see that, yes, this table has expanded. We have more models, and the coming of the 5 version has also uh, played its role. But you can see not every model is supported on every region. Let's return to our Foundry. Now, I will stay in the old Foundry. And it is a little bit more accustomed to everyone. So that's why I'm using the old Foundry. So you will see here these agents. These are the agents that are created once the backend is up and running. The first time the backend is up and running, it creates these agents. If the agents already exist, the backend just utilizes them. It doesn't recreate the agents. So let's see what are these agents are about. You have the design agent with the instructions, quite a long prompt. We need to be very specific and as more to the point as possible. So you can see here that we're getting executive summary, architecture overview, service recommendation with justifications, and this is something I want to make a pause. We won't get excellence if we're not planning for excellence on the first steps of our design. If my prompt to this design agent was one paragraph, the design document that we are getting here will be much more poor than what we're seeing here. You can see that the agent does exactly what we asked for. Executive summary, architecture overview, recommendations with justifications, implementation guidelines. Everything is sent by the prompt we created. And cost optimization tips. Very important. Plan ahead for your agents. This is my advice. Nothing else too fancy about this agent rather than the prompt itself. You can also have a description if that makes it better for you to understand what's going on. And here is the diagram agent. The diagram agent was really hard to make it work. So this is version A. Version A, you can see that we are trying to, to push information through the prompt to make the diagrams work. This is the leftovers, let's say, from our initial attempts to make the agent work as much better as possible without making errors. And you know, the problem was that if we didn't have the MCP validator, you may had one architecture correct and the second would be faulty. So in reality, this agent needs to be cleaned up with a better system prompt, remove a lot of unwanted descriptions about services, and you can see here that we are trying to guide this agent because in their small sandbox environment they cannot fit everything, and this is a limitation that we need to be very serious about it. As you understand, it is a natural evolution step to look other ways to make our grand ideas work. And what is the other ways for us? The MCP service. Let's have a look. Oh, before that, remember we have this my threads in the Foundry portal, and for each agent, we will see all the information, all the history that happened, and it is called thread. So we just had one interaction, and you can see that we have one thread for the design agent. You can see here also my prompt. This is the prompt created by the user input. Okay, the user input was not this one. This is enhanced in our code. And this is the requirement. The requirement is where my prompt starts. Let me see if we can, yeah, this the requirement. Design a scalable e-commerce platform architecture in Azure using authentication service, invoicing, and order management for 1,000 users. Average. Use color boxes to separate service boundaries. That's it. This is my prompt. The requirement in the design of this agent is only my prompt. Everything else is um, created for the agent through their system prompt. And you can see that reflected in the threads. So you can see also the response from the agent. The response is the document that we got. The same stands for our diagram agent. Here is the prompt along with the user prompt. You can see here how many highlights and only and not we have, with a lot of help for the diagram agent. They are able to create the correct diagram. Let's go and have a look finally into our MCP service. how this MCP service makes it real. And of course, we're going to use it and we're going to see important stuff. We're loading the CSV. This is CSV, not, yes, it is CSV and JSON. We loaded everything. This is the, let's say, the mapping from the diagrams library of all the artifacts that are required to create diagrams using Azure only architectures. The diagrams, let's say, framework has also other services. We are using only the Azure part. So we brought everything in a CSV format and we provided this data to our MCP server. The Azure nodes in a JSON file so it can have a better tree-like a reflection of what service belongs to which class. This is something that the diagrams agent would never be able to understand if this MCP server didn't exist. Never. And here we are. We have this MCP diagram server. This is our code. You can see here that we are reporting the relevant packages, model context protocol, right? We are importing the providers for the diagrams service, and we are analyzing everything. So instead of, you know, leaving it to luck, everything is set, existing, and provided as a tool. I'm sorry. So you can see here that this is our tool to validate the diagram code. Another tool to generate the diagram. What is MCP? MCP server, in our own words, right, is a server for AI agents that provides tools and context to help the agents perform certain tasks. Okay, so this is what our MCP does. And it's not always a good practice to fill up your server with tools. Okay, it depends on the case. Since this is a dedicated service for the diagrams purpose, it's okay. We need to be as more perfect as possible, or as more to the point as possible. So we have a lot of tools to make our world better. The version B of this service, it's really more smart. It's smarter, and we're also utilizing Azure AI Search. I'm going to say a few words about it later. And this is an enhanced Azure validator that helps the MCP validate what's going on through the user's input. We need an MCP HTTP wrapper. Why? A wrapper with W. Why? Because our agents are not um, Claude AI. Okay, they're simple agents, and we need somehow these separate container services to make them work with each other. So we're wrapping our MCP using the HTTP wrapper. And you will see in our interactions that there are also other cases where you need this wrapping of the MCP to be able to work over HTTP. Okay, it was not an easy task. You can see that a lot of lines of code, a lot of nights, and a lot of trial and error and start over. Let's have a quick look in our infrastructure. This is executed when you run azd init and azd app. When you run azd app, Terraform takes over and starts creating the resources in your Azure subscription. For Awesome AZD, there is a certain way to create your directory structure along with Terraform or Bicep, depends what you prefer. So you can see here that we are working a lot with variables, and this is how we are able to make everything automated. Okay, no human intervention while we are waiting for everything to be deployed. Even the Azure AI service, the agent service, is automatically deployed. And now that we are discussing this and I'm presenting this, I really understand why our dear friend from Microsoft said that this is something really golden, as exactly it said. And I'm sure that if we take this to the next level, it will be even better. The files that the Terraform needs also to be able to hold the environment name, the location. It asks you these questions when you first run the AZD init and then AZD app. The front end, let's have a quick look in our front end, and I want to show you something that's really important for React developers and React applications. Uh, you have your JSX or TSX files, okay? Now, something important. If you want to make Dapper work, you need to be able to create a certain type of configuration into your Nginx reverse proxy. Okay, the type of configuration is this. This is a very important step in your developer, in your deployment of container apps with Dapper. You need to pass this string, this type of URL, and you need to make sure that the backend service name is reflected right here. Why? Because we live in the same environment and each service know each other just by name. And this is where Dapper is exploiting and makes things much easier. You can see that we're using localhost. Why? Because it's actually the same server. If you want to have, you know, if you want to take it deep down in the actual infrastructure level. For development reasons, if you want to make this thing work and not be lost into the world of APIs and Dapper and all that stuff, you need to create this in the vite.config.js when you can create a proxy here that works when you call the API. It will be able to find it directly in your bucket without having to do a lot of stuff. Dockerfile also important because we need to build our containers. This is for the front end. You can see the two stages here, the build stage and the production stage. And finally, for the backend, the Docker file is here that is using the our Python code, and our Python code is right here. This is our backend. Let's see how we are building our this is our API. Okay, it's the actual how the backend is routing everything. Let's see how we're creating the agents. So this is the first agent, okay? And then we have the Cosmos file, how we're interacting with Cosmos, the storage. The storage was used if we wanted to store something in Azure storage and it was left there, and the diagram generator with MCP HTTP, okay? Yes, and if we want to have a quick look in our backend and see what's going on, let me see and show you what's going on here. So let's see here in the backend. I'm going to maximize this and let's go here and start design a new application. Design a scalable architecture of a web app in two different regions, East US and uh, North Europe, sorry, and North Europe. Let me fix this. North Europe. You can see here that we have this real-time validation happening in the background. Design a scalable architecture of a web app in two different regions, East US and North Europe, that provides authentication for 1,000 users and backend connectivity to Azure SQL or SQL. Let me bring the backend up. So it's this one. So you can see here that the backend is already has started working. Okay. We are getting logs from the backend. So let me press the send button, generate architecture. So our payload, our prompt, okay, it is reconstructed and sent to the design agent, and the design agent is currently creating our document. In the meantime, the architecture agent or the diagram agent is struggling to create the correct diagrams. It is referring to the MCP server in order to be able to get the correct names and the correct artifacts from the diagrams library, so it won't fail. This is the backend. You can see that a lot of things are happening here. Okay. If you want to, have a deep look, you can also expand or extend the logging or the debugging, let's say, and you will be able to see a lot of information, valuable information, especially when you are trying to make debugging. And this is something that's the most important part of our logs. Okay, this type of information. MCP validation is successful. These are the validation results. It's using the correct sub modules, the correct classes, the correct services, and that's why we're able to get our design document and the architecture diagram. Okay, it's using Traffic Manager. Why not? I think it's correct. East US and North Europe. My prompt is very poor, and the diagram is as my prompt is. Now, if we want to expand this, we will see more and more and more uh, diagrams, complex diagrams being shared, just like the other one we had earlier. I think it's this one. No, it's this one. This one is a little bit more complex. And also my prompt was more rich. So I think we went through a lot, and I'm sorry if I was a little bit more focused here and not to everyone, but this was and remains one of the hardest projects that I have ever worked on. I'm really happy and honored to have this as a Awesome Azure Data Blade, and my promise here is that I will make it better. Uh, Thanks to our Microsoft hero, uh, there are a lot of implementations that will make this service really, really better. So again, imagine implementing the MCP docs, documentation MCP, right? So every information, it won't be out of the model's knowledge, but it will be fetched in real time from our MCP. And imagine also using Azure AI search and embeddings to fetch information from pre-existing solutions created by the users. Also, authentication is something that I would like really to implement. So stay tuned. The links will be added by our lovely host, uh, Isabel. If I'm wrong, yes, I think Isabel is the correct name. Forgive me if I'm wrong. The links for Awesome AZD, where you will also find there this specific service named Agentic Azure Architecture Document and Diagram Generator with MCP validation. So that's it for me. My name is Constantinos. You can hit this QR code and you will find my details. Please ping me. I'm open to contribution and collaboration. So especially if you want to make this a little bit faster, move the phase that I just described, I'm quite open and I will find the time to make this work. Thank you everyone for being here with us today. I don't know if there are any questions that you would like to discuss with me. I'm open and it will be my pleasure. Connects with Microsoft Fabric. Yeah, that's a very good idea. That's a very good idea. Since we will build the secondary phase, we can enhance this library of artifacts by using content from Microsoft Fabric. That will be really, really amazing. And it will be one of a kind. That's a very good idea. Thank you for that. Yes, thank you very much. Very good idea. What I could really use is an AI tool in creating architecture diagram from my existing project Azure subscription. Yes, this is exactly what this thing does. Yes. So thank you very much. I think there are now other questions and our time is almost taken. Stay tuned. Next Monday and Tuesday again, I will be with you to present the second cycle of this series with MCP, and it's really interesting. As I said, we have a gradual scale on complexity. The third one that's coming up is about Streamlit and how we can use MCP clients and servers and HTTP API, the native way, clients and servers utilizing the same engine. It's very interesting. Many thanks to our host for having me and having us today. Wherever you are, have a great one and be safe, everyone. Thank you so much.
Thank you, everyone, for joining us today. As always, we strive to create excellent content for all of you, and we would appreciate if you took a moment to scan the QR code that is available on the screen and share your thoughts and comments with all of us about today's session. Like Constantino said, we do have 2 more sessions to go, and I have dropped a link in the chat if you want to register and join us for the remaining 2 sessions of this fantastic series. We appreciate your time, and we look forward to seeing you here at the Microsoft Reactor. Have a good day.